Hello, welcome back to nuk234. This is Immersive VR Compositing, and I am your professor, Daniel Smith, and welcome back to class number 2. The focus of this class is understanding pre-distortions, to understand the reason behind it, to understand how view-dependent imagery works, how to create view-dependent imagery, and how we can adapt it to the next level with moving cameras. So we're going to go through two different examples. First, we're going to set up a practical example using photography. This practical example is based on those internet videos that you may have seen where they talk about amorphic illusions. And they're all based on the same concept of view-dependent imagery. They only look correct from that distinctive point of view. But we're going to go through a very simple exercise on that. And then we're going to go into Nuke and we're going to build upon that, and we're going to introduce adaptive MPV, or moving points of view. So we can practically build something that is fixed for a particular point of view. In digital, we can take it one step further and we can update the sculpture or imagery or the two-dimensional image that we're looking at interactively, and through the process of rendering, we can continually change that point of view on a per frame basis. So let's get into this practical example. All right, so what we're going to do is we're going to start to set up our props, and we're going to take this roll of gaffer tape and we're going to put it onto a white sheet of paper. And the sheet of paper is particularly important here. Well, the white paper is going to be really important because we're going to put a grid on it, and that grid's going to allow us to use the 2D distortions to make sure that this grid becomes a square, essentially. And we're going to be doing that in a moment. So with my props arranged around the objects, and you can see here, we're going to rotate this a little bit, and we're going to have the shadow of the characters over here casting across the white sheet of paper. And we're going to arrange it so that way it has a three-dimensional look and some lighting. And then we're going to capture some of that lighting with a photograph. Here I took a photo of the prop, and this is what we're going to do is we're going to turn this into a two-dimensional image that can lay on the tabletop and look exactly the same as it does here within reason. What I also did was I printed out a grid. Now the grid is really important because this gives us, these are perfect squares, and we understand that those are squares. So by printing out this grid on the sheet of paper and then taking a similar photograph of the same prop over this grid, this gives us enough information right here so that I can use a corner pin to undistort this image. So I can turn these squares back into these squares. And then we can apply the same transformation to this picture. All right, so let's take this image here, and we're going to first of all, we need to create a merge, and we're going to move it over top of each other. And the reason why we need to do this is we need to put both of these into the same space, because these pictures, I tried my best to take the pictures very close to each other, but at the end of the day, they're very different. So let's go to a transform, reduce the size, We're trying to get the sheets of paper about the same place. Now the roll of tape is going to be a little bit different, and that's mainly because when I put it back on top, it did have some slight alignment issues. But what we're trying to do is we're trying to figure out that field of view calculation of how this is being distorted. So if we can unwrap that distortion, we can apply it to the other image equally. So there we go. So now we've got that going on. So I'm going to take the merge, and we're going to just kind of shove it over there. And now we've got our image with the grid aligned to roughly the same place where the without grid is, because this is the one that we want to deal with, is that one. So we're going to take this image and then we're going to crop it. Okay, so we're going to give it a little bit of a crop. So let's do a crop right here. And let's put this crop, let's get that image cropped out as much as we can, because this way we can just get rid of extraneous information. And now we're going to reformat this, and we're going to create a new size, and we're going to call this print res. And our resolution for print res is going to be 2550 by 5250. And this comes out to about, this image format is going to be 8.5 by 17 inches tall at 300 dpi. And that's going to be important for the way we print this. So with this going on, I'm going to hit black outside. And now we need to get a 2D corner pin. So with the corner pin, what we want to do is we want to move the from side to the four corners of our image down here. So what I like to do is I like to switch this to the image before it, so that way I don't see the distortions happening, because these placements need to be pretty accurate. We're going to put this to the four corners of the sheet of paper. And remember, we're going to take this sheet of paper and we're going to make it rectilinear instead of going into perspective. So let's go back to the corner pin, and that's pretty much what it's done, but you can see it's way too large. So what we want to do here is we want to quickly change our input from the without grid to our transform gridded paper. So this way we can see the grid and we can see how much distortion is in our grid. So go back to our corner pin, go to the to side, and this is where we're going to take these top control points and we're just going to grab them and we're going to lower them down until we create much more squared shapes. And we're going to straighten this whole thing out. Now, we're going to bring in the edge, we're going to take the paper to the edges right here. And the reason why is because that way we'll have an interesting edge and we can cut this out after we print it. So you want to get it as close as possible. Now technically this will be shrinking our image just a little bit. And we're going to bring down the top just a little bit more. Let's make sure the top of this, and I am pushing the limits here, right? This is very, very close to the edge of there. And let's bring in that edge of the roll of tape. Now, technically, this is a little bit smaller than the same size sheet of paper, but we can get away with it because it's pretty darn close. But the basic principle is the same, that we are taking an image that was originally shot like this, and we're using the corner pin to undistort this section here to make it rectilinear and square. And then we allow the rest of the image to take on its true distortion. Now you'll notice that the image where it's flat paper on the ground, on the tabletop, has minimal distortion. It almost looks like the original paper right here, except it has like little curls and, you know, some bends in it due to normal distortion. But the roll of tape, which is going up the y-axis in 3D space, as it gets higher and higher, the amount of distortion gets much, much more severe. And that's okay. So what we're going to do at this point is we're going to print this out. We're going to save this to disk, and we're going to open it up in Photoshop, and we're going to print it. All right, so now you can see right here is the printing. So I took that image, I printed it out on the printer, and then I had to cut with scissors and X-Acto around the border. All right, so you can see here that it's very distorted, but as I place it on the table and then I move the camera back to the position from which we took the original picture, you can see how the distortion now looks correct from that point of view. So in this setup, we have the real roll of tape sitting on top of the printed out compensated view dependent image. And we're going to move into the same position where both line up. And that reveals our true camera position. We also have part of the shadow from the little Doctor Who toy on top of the paper. Now, so far I've been showing you these images from a secondary camera. So let's take a look at some video from the point of view of the actual camera that took the original picture. So in this video, this is the camera that is filming the tabletop, and this is where we got our original image from. And you can see that the alignment to our image is pretty darn good. There's some color issues, but that was with our printer. But we've got our shadows, we've got the correct perspective right here. So I reach in and I'm going to start turning this away from the perspective, and you can see that it is completely flat image. And it only lines up to that one particular view. All right, so right here, this is the original, this is the real roll of tape, and we're moving around, and you can see the freedom of movement that we can get, and we can zoom in and we can zoom out. And now right here, let's take the real object off, and there is the printed out flat view dependent image on the tabletop. Zoom in, zoom out. You can see that it acts in a very similar way to the real object. And now we're going to remove a toy, and we're going to spin the image. And we can see that it is indeed very flat and not real. But you can see, as long as you don't create parallax with your camera, I'm rotating from the nodal point and I'm using zoom, the illusion stays solid. All right, so here we are back in Nuke, and now that you've seen a practical example of how this imagery works, we want to take it now into digital realm and show you the same concept, and and then we're going to adapt it for a better way. So here we go. We're going to go into our next section here, and I've already got this prepped, so I'm going to walk you through this. I've got this scene set up, which is basically a Rubik's Cube on a grid. So I've got my cube, and you can see that it is fully three-dimensional. It's made out of actual geometry. It's not flat. And it is a dimensional object on a tabletop. So just like before, we have this setup in which that we can understand every element of what we were doing before. So what happens here is that I've got a camera set up very similar to what I had before, which is, hitting it about a, almost like a 45-degree angle shooting downward. So we get this nice three-dimensional look. And if we look through our camera, we can see that the top of the image is poking over top of the tabletop, and we've got this nice arrangement. So that's what these nodes do here. They basically put together our Rubik's Cube, place it on a tabletop, and put it all together. And we've got our camera in this node right here. So the first thing that we're going to do is we're going to render this out. So we're going to render this out to a two-dimensional image here. And this 2D image, we can see it's RGB and A, and it's nice and flat and dimensional. So now we're going to take a copy of our exact same camera, but this time we're going to take a piece of flat geometry and we're going to run it through a Project 3D node. And if you're unaware of the Project 3D node, we can grab this from our shaders, and you see right here it says Project 3D, and you set this up very simply by it needs a camera and then it needs an image. In this case, the image that we're projecting is coming from this scanline renderer. So it's this flat image that we just looked at. So it's much like a movie projector or a gobo in a spotlight almost. It's going to project through that camera's point of view. So when we apply it to this card, you can see that it is literally like a movie projector. So let's put this over here and we'll rotate it around and get a little zoomed out on here. And we can see that this card is perfectly flat. It's not like what we were just looking at. But over here, you can see we have a three-dimensional cube. But what the image has done is it is now projecting straight out of that camera onto the ground. And in fact, if I take the camera and we move it a little bit, so let's just slide it along, you can see that it's moving that image on the ground. That's because it's almost like a texture locator. It's directly rendering that based upon its point of view. So we've got this going on, and if we take a look from our point of view and lock our camera, it looks almost identical to the original 3D render because we are looking through the exact same camera that we generated it from. All right. What we want to do now is we want to take that card right here, and let's imagine that we're no longer looking through that camera. So let's back out and let's rotate this up a little bit. And what we want to do is we want to look through an orthographic camera of a top-down situation. So look at that. Look at the way the image is when we look exactly top-down on it. So by taking that and running this through a scanline renderer, but switching our projection mode away from perspective to UV, what we're going to get out of the 2D render is exactly that. We have basically done the exact same thing in much fewer steps that we did over here with our real image. So with our photographed image of the tape, and we went through that process of doing a grid, and we did the corner pin, this is basically doing that exact thing, except it's producing a digital image. Now, that digital image is now going to be placed back onto a card. All right, let's see, let's go back to 3D, and okay, there we go. All right, zoom in, rotate, control left click. You can see that it is flat on the ground, but through the point of view of this camera up here, we're going to be able to see it from the exact same point of view. So let's view this scene and switch it to that camera. There we go. So you can see right here that so far I haven't done anything new. It's all the same stuff, right? So we've extracted it out, and then we've put in a new render, but we flattened it, and then we put it back on. So now if I show you this node here, this transform geo, what this is going to do is, like, just like in the practical video where I took the flat printing and I reached in and I touched it and I made it spin, this is exactly what this is going to simulate. So here we go. It looks perfectly normal, and then it spins, and we can see that, oh, wait, it's not. It's not normal. So it's actually distorted. It's greatly distorted, but it comes back to normal right here. All that being said, let's now take this into this next section here, in which now we have our flat image, and we've got two three-dimensional Rubik's Cubes that are actual props. One's behind and one's in front of. And I'm going to hit play on this, and we're going to switch to our other camera, and this camera rotates on its single nodal point and zooms in and zooms out. And you can see, just like our practical example, this optically is identical. All right, so we've done something here. We've basically, through all this process, I've recreated what we did already practically, but digitally. But this is where the fun starts, because what we're going to do next is we're going to add what you can't do practically. All right, so here's the challenge: is all these different things are pretty relatively simple to do, but what we want to do is we want to be able to move the camera in a more interesting way. So let's set up a new camera move, and we're going to do that by, I'm going to take the original camera and copy it down here, and I'm going to declone it because I don't want it to be affected. So this way we have our original camera move, and we're going to call this our move cam. All right, so I've got the move cam down here, and we're going to set up another scene node, and we're going to inherit the cubes from upstairs. So that way we've got these sorts of things happening down here. We're going to include our little card over here. So that way we basically have our same scene, but now we're going to add a camera move to it. And I'm going to do that with an axis node. So I'm going to put an axis node connected to our camera, and we'll call this one, it's our camera move, so we'll call it cam move. All right. So that being said, let's animate our camera move. So let's go to frame 1. We'll set a key for all our channels over here. And let's see, 1.4 and let's take a look through our camera. Okay. And like a little bit of rotation. There we go. That's more like it. So you see what happens now is as soon as we move away from that area, we get this kind of distortion. I can uncouple that and I can put that back. Let's go to frame 100, and on frame 100 we're gonna add a few more keyframes, like 4.5, move it on Z, 10.4, and we're gonna do an opposite 15. There we go. So now you can see that right there in the middle it looks right, but we want it to look right from every single angle, not just frame 55, but it should look correct from this angle all the way to this angle. And that is the key to everything for this class, is understanding that what we're going to do is we're going to pre-distort every single frame of our complex visual effect shot and have it be specifically distorted to the angle that we're looking at. So what we need to do is we need now to create our dynamic view dependent imagery. So that being said, we've got our camera move over here. Let's create our new version of this. So what we're going to need to do is we're going to need to grab our scene from over here. So let's drop a dot node down and grab that. We'll bring that over here, and we're going to produce a new scanline render, and we're going to use the camera over here, our move cam. So this way, out of this particular render, we're going to render this whole image in 2D, like so. So we're going to render this entire camera move from the right correct angle. But then, just like up here, we're going to need to do something. We're going to need to reproject our resulting imagery onto a card through its UVs. Let's take that card, make a copy of it so we don't have to resize it and stuff like that. And we're going to create a new shader, project 3D, and we're going to steal the same camera. So let's insert an elbow joint there and put that there, and we're going to project that render back onto that card, like so. All right, and now we need to create another scanline render, and we're going to connect that one up to here, but we don't need a camera. We just need to switch it to UV mode. And go to 2D. Awesome. So now we're rendering out a brand new texture for each and every frame depending on the same view as our new camera move. So this can get a little calculation heavy, so it's also good to set up a write node, and we're going to write it out. So let's pop that in here and go to nuk234. We're going to go to week 2 and images, precomps, and we're going to save it right here, and we're going to hit render. And also make sure that you switch it to RGB and A, because we will need the resulting alpha channel so we don't get black edges. And we're going to hit render, and I'm going to pause the video and come back when it's done. All right, so that render is all complete. Let's read it back in. There we go. And let's give it a little play. Let's see what this thing looks like. All right, so this looks really bizarre because it is changing on a frame-by-frame basis depending on the point of view of a moving camera. But you can see that it looks very awkward, and it just is stretching and moving all over the place. But we've essentially stabilized this image. It's a weird form of stabilization. It's view-dependent stabilization, because the ground is going to be static, so that's all stabilized, and everything, the further you get away from the Y0 axis, you can see that it gets more and more movement in it. But yet this is a static image. The movement is being derived directly from the camera. And that's an important concept that you got to understand, is that the camera is what's moving. The camera is what is causing the distortion. It's because you're moving from a different point of view. So let's pause that, and we're going to grab a apply material shader. We're going to reapply this new material, which is the new image, back to our video, and I'm going to hit play. Just see what is happening here. Let's close all these nodes out. Now look at that. What is exactly happening? Well, our camera is moving. Boy, we've got a little bit of shift in our texture there. Gonna have to fix that, but you can see that. Actually, you know what? I think that might be my cache. Let's clear the cache. All right, so cleared that up. It was a little cache issue, but no big deal. What's really important, though, is remember this is a moving point of view shot. So if I uncouple our camera and I actually move away from it, you can see that the texture itself is actually static and moving in that weird way. But the camera move is moving past here is correct. Now, this will, in our shot, will be a ride vehicle, a part of that location-based entertainment system, which we're going to figure out our camera move next week, and we're going to animate the motion base and get our shot prevised, and we're going to understand how our camera is going to move past our movie screen. And in this case, our screen is this particular object right now. But the core fundamental here is exactly the same, is that we're creating this animation based on what this camera sees. So that way when we play it back, but we move in that same way, it looks fully three-dimensional. Now, let's fold this into everything else and bring this texture, not this one up here, but bring this object with this new animated texture back into our scene. And you can see now we have our flat objects and we have our real 3D objects, and you can't tell the difference. You can only, it looks all blended. So we can have a practical real world set in front of our movie screen We can even have real world objects somewhere behind it, but not, if this one overlaps in front of it, you're going to see the breakdown of the illusion right there. So that's why I purposely kept it right on that edge. But it's really awesome because you really see the potential for this sort of complex effect. And if we break out of our camera move, we can see how that actually breaks down. So if we're not in the ride vehicle, if we're not seeing it from the correct point of view, everything falls apart. But when it is, this can be even stereoscopic imagery being projected with real-world 3D objects, and everything blends together. This is exactly how those ride films and those event location-based entertainment venues are created. And once we get this shot all done together, we're going to then come back in and we're going to create, from this point of view, a 360 camera that we're going to be able to experience it with our VR. Pretty cool. I'm very excited about this, and if you guys have any questions whatsoever about what you experienced today and how this interconnects, I've included this script with today's download so you can pull it up and make sure that you really understand this, because that's the cornerstone to the entire shot. Is we are going to be seeing how things look from a particular point of view and craft that particular exact moment to be seen from a very specific place. All right, so if you have any questions, hit me up in the forums, and I shall see you next time.